topics that we have coming up. There's one Friday at noon. There's another one in December. I think it's the second Friday of December, where we're focusing on semantic kernel or technologies that will help you build out your Azure AI apps, including if you want to add AI capabilities to existing apps. I'll stick this deck on my blog, which is at blogcodingoutloud.com, and you see other contact info there. I'm going to launch it. I haven't done it yet, but I'm going to launch an educational site soon called semantickernel.dev. Email is live, but the site itself is not yet. Hopefully this month. Now let's get into it. So the topic that I'm going to drill into is I'm assuming you've all played with ChatGPT and similar Microsoft Copilot, and you know about the chat app. Ask it some questions, get in a dialogue about that, about some topic. And that's a fantastic use of AI because it could bring information, insights, ideas, the thing you forgot about, if you're brainstorming, all that kind of stuff, front and center. Great use of AI. I'm going to talk about something a little bit different. I'm going to talk about giving your AI a goal, and we're going to go over briefly how that would work if you were building something in semantic kernel with C#. And then the techniques that we're going to show, you'll see a couple of the references to Azure OpenAI or OpenAI. But the techniques, one of the reasons to use semantic kernel is that it's happy to work with many LLMs, many large language models. So it will work with OpenAI. It'll work with the OpenAI models run on Azure, and those are referred to as Azure OpenAI. And there are lots of other large LLMs from big companies that have support through semantic kernel right out of the box. I won't get into all that, but just letting you know that is a generalizable, portable solution. So let's get to the crux of this talk. Suppose you want to give your AI a goal, and you don't need to read all this, but basically this is a prompt, the thing that you hand the AI and ask it to do, come up with some results for you. This is a prompt that represents a goal that I want to give the AI, which is to do a little bit of work for me. And we're going to see how we do this in semantic kernel. So this is not a, so you see it's a template, right? Because it has the replaceable value of brand. And in the context of what I'm doing, just let me give you a little bit of background. I tried writing an AI, kind of like an agent, that we'll look at in a minute, that will solve the following problem. You want to use a logo. You need the logo for Python because you're going to use it in a presentation, or you want it for C++ or a .NET environment or Azure or whatnot. And logos can be a pain in the neck to find. If you're trying to build a well, we're right there. We can use AI to do the parts I already mentioned, and then maybe you also want to, in a website, say you want to represent the logo in a way that is helpful for somebody who can't see it, maybe the visually impaired. So maybe you also want to come up with a description of what does the logo look like, not just that it's the Python logo, but it's in this shape and so forth, to be a little more descriptive for somebody who can't see it. And you can go on and on. You'll see the pattern here, but I'm just trying to use a few very simple requirements to represent the generalizable pattern. And the pattern for following this goal is essentially we're saying that that we want just like in Hollywood where they say, don't call us, we'll call you. We want, instead of us making a call into the AI that says, hey, give me an answer to this, we want to give control to the AI and say, hey, here's a toolbox you have, some functions that you can call at your discretion, AI to solve the problem, to achieve the goal, and so forth. So let me show you what I mean. I'm go over to look at some. I'm going to go to the command line here, and just to show you what I'm going to do. So .NET Run is how you run a .NET application. I have a console application that I've created. We're going to look at. I'm going to give it a command, a command line parameter just called Python. This is the Python programming language. I'm going to hit enter, and it's going to complain that please set the environment variables. So in order to access an AI resource like OpenAI or Azure OpenAI or Llama or whatever, you need to get an API key or the other or whatever means you have. You got to get a secret. So I have some secrets all set up here. I just wanted to illustrate that these are all coming from the environment. These are all environment variables, and they can be pulled in. And you'll see a couple of places in the code where that matters. Now, yes. Let me do that. Give me a second. There we go. Now let me run this again. Oops. Run that again, and we'll see the results. Then we're going to go see how we built it. So what I'm asking for this program to do is I've given it the goal of get a valid URL, make sure the URL is valid, create a description of the image on it, and oops, I'm sorry. That's actually not what this does. I'm sorry. I did something out of order there. Basically, I rather than do that, I have a simpler prompt there that says, tell me about the Python community. And it gives this big, long, nice description of the Python community. Let me go into the code and let's see what that did. I got some using directives in C#, a load of the configuration from the environment. That's what I showed you. I ran that from the command line to set up the environment variables. I get the command line from the command line. I just concatenate all the values. So if you say Python community, it turns that into the replacement of the variable brand that was in the goal, remember, in that big prompt I showed. And it does some semantic kernel stuff here, creates a builder. There's a few lines that are just kind of boilerplate. Actually, it's using this one. It adds the Azure OpenAI chat completion service. Again, like you don't really need to, we're not going to really talk about this, but this is just the way that you interact with semantic kernel. You set it up. And I pass it in a few values that I got from the environment, including an API key over here. And you build it. And then there's some plugins we'll come back to. That's going to be the heart of the conversation. And we're going to bop down here to, this is the prompt that we're currently using. We're not using the big goal-oriented prompt I showed on the slide. This is what we're going to start with. Tell me about the brand community. I said Python community. And it invokes prompt async here from the semantic kernel. Just passes in the prompt with a Python community in it. And it outputs that big, long thing that we saw on the command line. So standard use of AI. Let's constrain it a little bit. I'm going to pass in some prompt settings, prompt execution settings. That's this thing up here. And I'm going to say max tokens to 50. Back here, I'll run this again. And you can see that it's actually useful information that it returned. A vibrant, active community. Here are some key aspects of the Python community. And then it stops mid-sentence. I didn't give it enough tokens. I'm going to back up to say 750 tokens. Just pointing out, like this is the unit of work that you do that the AI does for you is measured in tokens. You pay for the tokens. And if you don't have enough tokens, you get a truncated response or a less sufficient response. So just pointing out that's part of the machinery in semantic kernel that you can make those adjustments. We'll see tokens again shortly. I'm gonna override this prompt. I'm going to change it to this longer one that you saw on the slide. And I'm going to run it again. So tell me about Python, except this time we're trying to get a URL and we want it to describe the URL for it. Pretty straightforward. So it got a URL. It's validating the URL. We'll look at that. It created a description of the URL. This came from an AI just now. The image. This is the Python logo. The Python logo. The image depicts the Python programming language logo. Features two stylized snake shapes, blue and yellow, coupled with the word Python written in a gray modern font. And then it gives us that in, like we asked for in our prompt, as HTML. And we should be able to pop that up and see that that's actually that's the logo it found. And those are the two, blue and yellow, intertwined and so forth. So that went pretty well. How did we do that? We'll get into how we did that. Let's try it again, actually, just same thing. The AI is stateless, so and it's non-deterministic. So we usually get slightly different results every time we run this. So this description is a little different the second time, like it ends in written in a gray modern font that first time. And the phrasing is a little different. So normal standard AI stuff, the AI does not behave predictably. You don't get exactly the same results. This is a huge change from normal traditional programming. Let's go in and see how it did that. So the way it did that is once we gave it these prompt execution settings, we told it about max tokens and temperature and so forth. We could talk at question and answer time if you're wondering what temperature is. But basically, it's this one line that made the big difference. This said function choice behavior auto. This is telling the AI to decide which functions to call. Which functions does it have available to call? That's entirely up to us, and these come in the form of plugins. We've registered basically 3 functions that the AI has in its repertoire. One is the icon finder. This is the thing that comes up with a URL. This one is a URL validator. If it comes up with a URL, this thing validates that the URL actually resolves and points to an image. And this third one, once we have a URL in hand, we can ask the AI to describe it, to come up with a description of how the icon or the image appears visually. Like in the Python case, we talked about a couple of snakes or intertwined guys. So let's look at these 3 functions. I'm going to go back to the slides for a moment here. The first one is in something called promptee. We'll come back to that one. The second one is a function that validates URLs. We'll come back to that too. And the third one, describe image at URL. We're going to start with this one. When we have an image that we want to we're ready to describe, we've already validated that it resolves. Well, the AI has done this. We write a little debug message. We'll see this in the terminal window. We'll see this in the terminal window. But this is the function that this is code in our project. We register it with Semantic Kernel, and this is what it thinks the name of the function is. Semantic Kernel, the AI uses the AI, and the AI knows, all right, I have the ability to describe an image at a URL. There's a function that does that. And it returns a concise text description of the image, and it accepts a URL as a parameter. That's all it knows. These 3 things highlighted up top here. And we have elided this a lot. This is a shortened version. This actually uses OpenAI directly. The rest of the application uses Azure OpenAI. but this asks OpenAI, the Chat GPT 4.0, O for Omni model, which deals with multiple modes, including images. We give it a little prompt that says describe what is depicted in the image, and we pass it the URI to the image. It'll grab that image and do what it did, like you saw it work. That's one function at the disposal of the AI. This is another function at disposal of the AI that just says, validates a URL and it accepts the URL itself, and it tries to resolve it. Returns true if and only if it resolves. And hey, keep retrying if the first one fails. Again, another debug message. And basically, if you know C#, you see that this basically just tries to pull the image based on the URL, and it puts a message on there if it doesn't succeed. Pretty straightforward stuff, the implementation of this function, but as far as the AI knows, it has a capability to validate that a URL resolves. And then I mentioned this one, that's the icon finder. Let me go to that here in the code. And this is in a file format that the prompty file format, and this is YAML. And the top stuff here above this, between these hashes, these three dashes, up and down dashes, is the front matter, as it's called. And then here's a prompt. This is the prompt that this is all representing. You're an AI assistant that finds URLs, and it describes what it means by a technology brand like GitHub or AWS or Python. As the assistant, you provide the official URL to the logo in ping format. You provide the URL only, and it goes on to say, like, put it in this JSON format so that we can easily parse it. And there's some other stuff in here, but that's that has to do with the prompty format. Prompty is that's an open source, essentially an add-on to Semantic Kernel from Microsoft, and it's so it allows you to concise or in detail describe your prompt. And you can see here that it also references the same environment variables that the application it was using to load itself, to load services from the Azure OpenAI LLM. With Prompty, you can test your Prompty by running it here, and it's hitting the AI that's been configured. What is that? Not sure why it's grumpy suddenly. Let me try that again. Okay. I goofed something up. I'm not going to debug it here, but you should be able to run it and see the result. See a result that looks like this. So take my word for it. But let's go back to the program. So again, this is the load these functions. They live in what's called plugins. Won't really get into that, but plugin can have multiple functions. I just made one function per plugin here for convenience. But one is loaded from. So this is the text prompt you just saw in the prompty file, and these are the two. We're not going to go look at the code any further, but this is how they're loaded into Semantic Kernel itself. And we saw the key points out of these functions in the slides. So I've given the AI a palette of 3 functions that it can call. It decides when to call them based on that prompt that we saw in this slide that substitutes the brand. Let's go back here and let's try this a couple other times. Let's do C++. You can see it's trying. It's failed because the validator tried to validate that it found a resolvable URL. And if we look here, that is resolvable, but it failed it because it wasn't a ping or a JPEG. It was an SVG. And it keeps trying SVGs. finally tried a ping, an svg.ping. That's interesting, but this just doesn't resolve. And it kept trying. Actually, it looks like it tried some of these in parallel. Remember, the asterisks are validating the URL, and the hashes are trying to come up with a text description of how the image looks. So it looks like it's doing some of these in parallel, even though these are failing. It's trying some of them in parallel, but ultimately it found one that looks like it succeeded for C++. Let's see if it did. Yep, that's a valid logo. And then it came up with describe the URL, and it image depicts C++ language logo, stylized C, couple of plus signs, and so forth. Then it outputs the HTML for us. Logo of C++, like we told it, and the fancier description as the title. So the AI, this is pretty cool. The AI decided to do the validate URL and describe the image at the end of that URL in parallel. Didn't wait till it had a validated URL, it did them in parallel. But it doesn't always make that decision. Let's even run the same one again, see if it makes the same decision. Sometimes it does them sequentially. It waits until it has a valid before it tries to come up with a description. And in this case, it looks like it tried multiple URLs in parallel, because we have 1 and 3 succeeding and 2 failing. So this is the AI making a different decision. It waited until it had a valid URL before it tried to come up with a description of it. And it came up with a different description this time. It's a non-deterministic machine. And here we are. And it worked fine. So it worked differently 2 times in a row, but it worked both times. It doesn't always work, though. I noticed it seems to have trouble with, way down here. Sometimes there's trouble with Java. And can't tell if this was parallel or sequential, because there was no error to go by, but this worked fine with Java. That's it. We have we could enhance this. We can make sure that this actually worked. We could enhance this with maybe the create a for function that gets what are the rules of using this logo? Like, do I need to put hey, this is a trademark of XYZ, that kind of thing in there, or not? But you could keep extending this. You can make a little change. It says logo of XYZ, which has been doing faithfully. We can maybe change that to XYZ logo. It says logo of XYZ. That wasn't that was just an example, right? I said, hey, do something like this, but let's run it again. Let's see what happens. And where is it? Java logo. So now it conformed. It's just showing that just by tweaking the prompt, our results have adjusted, and that is actually an accurate logo. So that's what I wanted to show. Don't call us, we'll call you. That's a powerful way to write an app, give it a goal, and let it complete the goal. And that's what an agent does. An agent, you give it work to do, and it goes off to the side and does it. And it can make some interesting decisions on how to do it, as long as you give it the tools. And Semantic Kernel can help you do that. That's all I have. Any questions? Okay. Thank you. Thank you for the feedback, folks. Very nice. If there are no questions, you can ask questions later, but I'll stay on, of course. but I'm going to flip it over to Jason.
Cool. Let me share my screen. Just gonna get this off so we don't get the exception thing going here. Share screen. Go. Can you see my blue screen? Lovely.
Yes, sir.
Cool. All right. So, trying to figure out which multi-screen problems here. So the first world problems, here we go. So I'm going to cover things a little bit in a different aspect. So Bill showed us quite a bit about prompts, making calls, validating and images, and a lot of useful stuff. I'm going to flip and move to some web UI for you guys. So what I am going to look at, I have 3 demos that I want to show you, but first I want to show the Smart Components, which is a open source project. It is a set of components that you can use in either Razor Pages or Blazor. Bring these over here. That behind the scenes uses AI, so it allows you to work AI into your applications in a different way. And then let's look at basically 4 pieces of this. There's not a lot in this. I've got the links of the GitHub repo at the end of this slide deck. So after that, I get done with the showing you guys this stuff, then I can show you the links, or I'll put it on my blog tomorrow so that you can download it and get it playing with it. So Smart Paste is a really interesting, and I'm looking at the Blazor version instead of the Razor Pages version, but they've got similar functionality in both. So, all right, so just pausing here. All right, cool. So the scenario, you might have a form where you have a name and an age, and say you want to be able to copy and paste something like name, age, or even better, something that requires some math. You've got a name, born 19th of September 2003. You've got this text somewhere, and you want to be able to fill this form out by just taking what's from the clipboard and pasting it into the form by pushing a button. So that's kind of interesting, but let's look at the mailing address, because this is something that's probably going to be a lot more useful, where you would have someone's email address, or not email address, name, and you would need to dump it into a form. Browsers try to guess, and that's what you've done before, like with an address input. It knows that you've used a specific value in a past address input, and it tries to pre-fill it for you. But this is another level. So I copied this text, which is a guy's name. It's information about the gentleman, but not his address. It's not an address format like I would copy out of a website or something. So I copied this, and then I say Smart Paste, and it picked out his name, but it did not pick out his address. So let's look and see what it did. So on the back end here, let me show you I've added some console writing to the code base so that we can see what it's doing behind the scenes. So this was here's the September 19th one. So this took information from the form, from the web page, and then it took the clipboard contents, and then it made a call to the LLM with this prompt, and then it returned this text. Or no, sorry, this is the message going there. Okay, so here's his name coming back. So it's taking the text off of my clipboard from before. So what I need to do is reset. I must not have done my copy paste error. So let me copy that again. All right, let's just make sure that we copy it. And we do a smart paste. And there, so we've got the name filled out, and then the address lines all from this little paragraph. So let's look at the and see what was passed this time. So this is what came back. So let's go look at it backwards here. So this is what came back, telling it the component running in the Blazor code that to put these values in. So the text that went off to the LLM is here. This is the prompt. Current date is, so the prompt has a part of it where it plugs in today's date in case it's needed for some of the copy paste. And then the stuff, it has this prompt here, which I won't be able to show because it's in a command line, but the prompt is here, very short and sweet, and then it pulls the information out of the clipboard and gives it to the LLM, and then the LLM responds with the data, and then the control will then put it into the UI for us. So that's smart paste. That's another example would be like a bug report. So if you take maybe a question that was emailed to you, and then you say smart paste, see how well it fills out this one. It's not doing anything. What do we got going on here? Anything? Okay. So add current CMS provider. So it came back. Let's see if it updated. It just took a little while. Okay, so it did populate. It populated project, it populated item type, a severity, title, and summary. So it's trying to add some smarts to stuff that's from your clipboard and taking information about the form information or the metadata of the form on the HTML and filling it out for you. That's how Smart Paste works. Smart Text Area, this is slightly different. So by default, it has a role in the declaration whenever it's dropped on the page. So in this case, the role is set up to be an employee inquiry. So if I type something like, what is the sick day policy? So it starts to take the information. So given the role that this text is coming from, predict what would come next. So it starts to do autocomplete for you. And let's see, just see what it comes up with. Sometimes it's interesting. But it just keeps adding this stuff in there. You can configure this one a bit more. Sometimes it does kind of become gibberish after a while. But so this is a preset for, this is a demo preset for an OSS, an open source project maintainer. So maybe a message would be something along the lines of, did you open an issue? And I just hit space, and then it comes up with this text. Could you please post a screenshot of? Okay, take that, and then see if it comes back with something else. So let me check the text here. So if we look at the prompt for this one, so this is the prompt going. So here's the role's not the role is 0. Let's see a role 0. Okay, anyways, role maintainer of this open source project. So this has basically it's like a few shot prompt. So it gives some examples of roles and then text. So this is the text, the running text that's coming back with the prompt. So this is actually kind of autocomplete text, which is kind of cool. One of the other ones is here. So one of the others is really cool. So C# code completion. So see if this reminds you of GitHub Copilot. See if any of you guys use this. So if I say int I equals, okay, 0, 4, okay, all right, okay. So nonetheless, this is kind of autocomplete in a text area, and this is the Blazor version, but there is a Razor Pages version as well. So that shows you how behind the scenes it's just creating a prompt. So it's taking some information in from the UI and metadata about the UI and giving it a role in crafting this a message. And with the user interaction, it then starts predicting what the user wants, and then the UI component nicely puts it there for autocomplete. So again, that could be useful in your own application. There's a third control that's provided with this smart components, and this is a drop down that's going to be doing a semantic search, which uses embeddings on the back end, which we'll see a little bit more of here in a few minutes. So expense category. So say I'm traveling and I am eating out. So let me say dining. So dining out, okay. So how about another category, hotel? So hotel, that would be, I don't know, hotel. So that'd be a travel. So the idea here is I'm typing a word, but it's not a valid category, but it comes back with a list of semantically similar category names. So this helps in the scenario where you may not know the exact name, or you want to see a listing by meaning versus the exact alphabetical order per se. Another one, so this is be like an issue label for support site. So let's say broken. It's broken. Broken. Question. I don't know. Anyways, so this is the same idea. It's just a different set of categories that is giving. So these both work off of embeddings. So embeddings are a way to do semantic searching, or that's definitely a broad and oversimplification of it. But behind the scenes, what we have are these vectors of floating point numbers, and they represent meanings of words and their relations to other words. And to give you an example, let's put some words out here that are similar. So let's say colors: blue, red, yellow, golden retriever. Cat. Oops, cat. Now let's do lowercase cat. Okay, cat and cat are 100% the same. Okay. Boat, house, computer, moon. Okay, so you can see the colors. So the yellow, blue, red. I'm kind of surprised the computer's in the middle here. Boat, cat, house, golden retriever. So they start to sort in order semantically. This is a local embedding. So this means that I'm not using the OpenAI text embedding service. There's several embedding services that OpenAI provides. This is using one that's actually running on my machine. So I'm not having to make a API call. And the cool thing about that is you can put it into your .NET code. It's running locally on my machine. It's not resource intensive, and it's relatively good. So let's look at another example of using those embeddings. So I have any questions while I'm bringing this up? No questions? All right, cool. So the database that I'm using for this example is the AdventureWorks database. So if you create an Azure SQL database, one of the options that you have besides creating a blank database is to use a sample database. And that's what this database is using. So what I've done is, let me find the, actually, let me open the, yeah, so this is Azure SQL Studio or Data Studio. This is the database that we're looking at. It's got all of these sales LT, product, customer, address. So these tables, not the ones that end in embeddings, I've added these, but it's got product information, it's got some sales information, but we're not going to be looking at that. So what I've got are a lot of embeddings tables. So SQL Azure now has a public preview for storing vectors inside of a table. What that allows us to do is store those embeddings as a native type in SQL Server. It was possible before, but you had to do like a column span index, I think it was. So you ended up with a very, very large table of a bunch of floating point numbers. But now what it allows us to do is, for example, the ADA2, the text ADA2 embedding is an OpenAI embedding. It has 1,536 dimensions to it. So it's an array of 15, well, almost 1,600 floating points. But with this type, it's now one field in my table versus a link to a table that would then have 15 or 1,600 rows in it. So this is just one single field that now contains all of that information. The local one that I'm using only has 384 dimensions. So it's a smaller vector coming back. It's not huge like the OpenAI. So this is the database that we're looking at. And again, I'm going to be showing you kind of how the embeddings can be different between the two. So I've just put a UI on the AdventureWorks database here to give you a sense of what we're looking at. So we were looking at the local embeddings and how it will order things. So let's look at categories. This has where I've got the lists. So say you have a web application like this, and you have a list of categories that are so diverse. So, we've got shorts, we've got bike racks, we've got bike parts, we've got cleaners, chains, more bike parts, gloves, handlebars. It's very diverse. And if you alphabetize this listing, it may not be as intuitive to a user to look at to find that specific category. We're looking at categories here, but it could be products, it could be product models, what have you. But if a user is looking for something in their mind and it's jumping all over the place, it's not as easy to find. But now when you sort these using an embedding, then they're a lot easier or a lot more user friendly to find, because not only are they somewhat ordered in how you would think of them, like the ADA one actually, so this is the OpenAI embedding ADA, was it text embedding ADA 2? This one actually is a little bit better than the local for these category names. And that just points out that the embedding models aren't the same. They are going to behave differently, and you're going to find that one embedding model may very well work for you better than another. And you may find that once you start to use them, you may want to fine tune your own with some sort of a vocabulary that would be geared towards your specific industry or domain. But like, look at this. We have accessories, clothing, socks, tights, shorts, bib shorts, vests, helmets. So these are kind of related. This is something I would wear. The helmet. Okay, same thing. Headsets, jerseys, bikes. Okay, so now we start off with bikes. Now we're going into more relatively related products that are bike related. You've got frames, you've got racks, you've got different bike parts, wheels, brakes. So this list is semantically sorted. So it has more intuitive feeling to it. If you're trying to find a specific category, but you're not, you in your head would know that it's a bike part, and it should be in this section of the list, not something down at the bottom. But however, I say that bottom brackets, I would think that that would be part of a bike part. I really don't know what that product means, but the crankset, same thing, tires, tubes. So we kind of have a gap here where it's gloves, cleaners, pumps, lights. I guess lights would be possibly a part of a bike, but as you can see, it's not perfect, but it does make it a little bit easier to find intuitively than just this alphabetized diverse listing. So anyways, this is comparing alphabetized, a local embedding versus the OpenAI embedding, ADA 2. There's an ADA 3 small and then an ADA 3 large as well, but this is just one of those. So the other thing I wanted to show you here And this is the whole reason I wanted to use the AdventureWorks data set, was to show you the idea of similar products. So say you have a website like Amazon, where you have a product, you have got information about the product, and you've got different colors. Just one only comes in yellow, but different sizes. This will allow this, what I have here, again, I'm comparing the local and the added to, is similarity search. So this view makes more sense to me. So we've got similar products to this product. So this is a short sleeve classics jersey, but technically in the database, and this is what I'm finding with these sorts of applications, and when you put Gen AI type features into an application, is you do spend quite a bit of time on the data. So it's like a third of your time on the data and analyzing the data, figuring out how the data should be shown, how to tell whether or not it's correct. Like we were looking at the embeddings, like trying to pick apart which ones should be sorted in a different manner. Looking at the data, where in a typical application, it's like, okay, well, it's alphabetical order. That's it. It's either not ordered or it's ordered. So there's not that level of focus on data. With these applications, you tend to focus a lot more on data uh, than you would a typical application. But maybe a third of the time focusing on data one way or another third on just application stuff, like putting together the UI, laying the stuff out, and then another third that may be the generative AI stuff where you're calling a large language model. But with these, this makes sense where we're showing the similar model or the similar products, but it's a product model. If you just do a product, so this is a product. If I go to this shirt for this, I'll show you, you'll see the difference here. Well, I'll just pick shorts, doesn't matter. So this is by product. So this is the product name. It's the shorts with size large. So you'll also see other products that are very similar because they're either the same shorts or they're just a different size. So like mountain shorts. Yeah. It's funny that the other size mountain shorts aren't coming back as similar products, but you can see this one versus the other. This is finer grained, but you would think if someone's looking at a large, they're probably not, they're probably not going to want to look at large men's. Maybe they would, but maybe not. Um, it would be up to you to decide that. But if you're showing similar products, you would probably want to focus on the data a bit more. Like, okay, so this person's looking at women's size medium. You might want to show a size up and a size down, but you wouldn't want to go like extra large. So again, you've got one level simply by just getting similar items using the embedding, but you would need to do some additional work on top of that to really craft it and be able to get that recommendation system going more or less of similar items. So that's the information I wanted to show you with this demo. So this was, again, mainly around embeddings. And let me show you what the embeddings look like in a database here. Actually, let's look at this. So this is, let's look at, well, it won't matter. You won't really be able to see too much. So the ADA to, let's see, select the top 1,000 here. So the database, you can see we've got, this is what I've done in this one is I've created additional tables to store the embeddings. Instead of putting a field on, say, product model and sticking the embeddings on the product model, that would be one way to design it. But I didn't want to modify the existing tables because there are views, there are stored procedures in this database. And again, this may be a way that you would fit it into your applications. You would create a table that is linked to the table that you want to connect the embeddings to. And for me, it actually worked out well for this demo, so I could do the comparison. And I didn't have to add a field for the ADA embedding and a field for the local embedding. I broke it out into its own table so that I could blow them away, repopulate them relatively easily, and I didn't have to worry about touching the other part of the table. But you can see they're just floating point numbers. It's just an array of floating point numbers stored in there. So that is the data. Let's look at another one. So what I'm going to show you now is this lab. So this is, well, you can take the link now if you want, or otherwise we'll definitely make it available once um, once this is done, and I'll be writing a blog post about it tomorrow as well. This is a lab that walks you through creating this application I'm going to show you. So this is a chat application. So let's set this as startup. Oh, I gotta stop it first, sorry. Stop, set as startup, now go. So it's a chat application. It uses Semantic Kernel, it uses Entity Framework, and it uses Azure SQL. So the idea is there's a PDF that I can chat with, and is this one, let me show you the PDF, and then I'll show you a little bit of the code, but let's take a look at the PDF first. So this is the PDF. I downloaded it from someone who shared it on the authors that shared it on LinkedIn. So it's a taxonomy of RAG, basically. So it's a short paper or ebook, if you want to call it, on RAG, basics, pipeline design. Okay, so let's just randomly go to like the middle here. So pipeline design, query routing, hybrid retrieval, iterative retrieval, recursive retrieval. Let's ask it, what is hybrid retrieval? So it's going to come back with a bunch of text before it comes back with the answer. And this is due to just some debug code that I have out or in the code, and it's also in the lab so that you can see what it picked out as similar pieces of text out of that document. And I'll walk through how this was pulled out in a second. So in this application, the lower the number, the closer it is to the question that I asked. So my search string was, what is hybrid retrieval? And it looked through the database, which I'll show you, and it came back with this one is 0.17. This one's 2.6, so this is less similar to this one. The next one's 26, 26, and 26. So I've got it bringing back 5. Typically, you would use like 2 or 3, not necessarily 5, but for the demo, I wanted to bring back more. So those are the similarities items, similar items sorted by the most similar at the top. And then it passes it off to the LLM along with the question. It says basically what the user's question and then the sources to answer the question are the similar results. So hybrid retrieval is a strategy RAG systems that combines multiple retrieval methods to enhance retrieval accuracy. So it came back with a decent answer. Things that would typically be added to this would be citation, like, okay, so where in the document did it find where in the document did it use to come back with this? And that isn't in the lab, but this is basically a RAG implementation. So what are the pieces of it, and how is the lab broken up? So the lab starts off with creating the database. So the database for this, actually, let's see, let me switching to the this data studio. I don't usually use this, but it does demo better. So because it scales and the other one doesn't. So this is the database tables that are in this lab. So there's a document. So the premise is we have that PDF document that I showed you, and it's going to chop it up into pieces so it basically opens the document, gets all the pages of the document, and then it splits the document up into paragraphs and then creates chunks with those paragraphs. The document metadata columns, is basically the name, the path, a create date. Page has a little bit more information, mainly relating to actually doesn't. It has just ID, document ID, and the number of the page. The page chunk is the one that's got the more information. So it has the relation to the page. So, we're building a hierarchy here. So you have your page and then all of the pieces of the page, which is the pages inside the document. So we have the created. So these are the typical keys at the top and the metadata about when it was created. The number of the chunk, so we know how many numbers, and then the text of that chunk. And then I have two embeddings on this one, which in the lab, it only has one embedding. I took the added two out. It's just a local embedding that the lab uses. So if I look at this, so if I say select top, so this is the page chunks. So let's just scroll down to random place. It looks like most of them are just one chunk. So when we looked at the PDF, you could see that let's see if we can copy this and open it in Notepad. Okay, so this isn't going to scale either. So this is word wrap. This is the text coming out of that PDF. And this is something with your own applications you're going to have to really also figure out. So this is probably the footer, simple guide to generation. This is probably the header. And if you're creating your own RAG application, would you want the header and footer in each page chunk? Maybe you would, maybe you wouldn't. These are things that you'll have to take into consideration. So if we look at this, see this is the header, and then where's that footer? Pipeline design. So the simple guide to, yeah, interesting. I don't see the footer in there. I only see the header. Interesting. Maybe it's actually part of the text. Simple guide to generation. This may be a heading with the going into the next one. I don't know. But nonetheless, you have to, again, pay attention to the data to see if it's being broken up in the way that you need it to be broken up to make the most sense. So this, okay, so that's the data. The embeddings, again, not very exciting, just a bunch of floating points. The code, so here, let's look at the code. So whenever you're doing the lab, I've got to get the right code up here though. Here. So first is the database creation, and then the second is to go through the creation of the data context or the DB context. So actually, let me show the configuration first. In order to utilize the vector support in Azure SQL, you need a few things. You need at least three things. One is you need the reference to this NuGet package. This is the one that makes it possible to utilize this extension here. It says use vector search. So whenever you add your DB context to the dependency injection container, and then you say use SQL Server, you usually pass some sort of a connection string. This extension adds on the ability to be able to do this vector search that we'll be doing. So this is one piece that's necessary. Whenever you're configuring your models, so in the model creating section, there's the type. So this is a new type in the SQL, Azure SQL. So like I mentioned, the vector size is a difference between the local and the OpenAI embedding. So you have to declare what size of vector you're using. So you can't just swap one out for the other if they're different sizes. So in this case, I'm really only paying attention to the local one. I don't have the code in this application to to make the API call out to OpenAI. So this is the second part, this extension method right here that says a column type uses a vector. So that's the second type of configuration. With those two, that allows you to take a float array on a model and save that to a vector type in Visual Studio and in SQL Server. So with that information I've given you so far, you can connect your application code to SQL Server in Azure and tell it you're going to be doing a vector search. Then we connect it with the model to create the vector type. So the lab walks you through the migration. Basically, you create this out, and then you run the migrations, which are stored here because I've run them. And then that will add the table with the vector type into the Azure SQL database that you create early in the lab. So that's the data part. To query it, so the querying, we have this DB service is sort of your typical repository pattern. It's wrapping the DB context. This is where you get all documents, get a single document. Does the document exist? Add a document, remove a document, remove all documents. So this is kind of a repository. The actual vector search is done in the what we call the retriever. So the retriever is taking in the database context, and this is the one that's taking the text. So that search text that I gave it is what is a hybrid no, hybrid retriever? It was a hybrid retriever, I think I asked. So it would be taken in the search text and then how many, which I've got hard coded as 5. And it uses the local embedding service. So this local embedding service is available using this NuGet package, the Smart Components Local Embeddings Semantic Kernel. That's the one that we saw in the Blazor demo to start off with. So that type is available out of that NuGet package. And that allows us to pass the text in and get embeddings back. So it's going to, it technically returns a read-only memory list of floats. So we have to use this to float array to convert it to a float vector. And then we can use that float vector to do this extension. And this is also available only from that NuGet package that we included for the entity framework vector search. So it will do a vector distance. We're going to ask it to do a cosine. There are a couple others that it knows how to do, but this is another thing when you're looking at your embeddings and what works best for your scenario. Embeddings typically will tell you which type of similarity you should use. Should you use a Euclidean dot or a cosine? Sometimes I hear dot and cosine used the same, but typically it's cosine. I believe with OpenAI's it's cosine similarity. With the local one that I'm using, it also says to use a cosine similarity, and it's document information on Hugging Face. So what this is doing, I mean, the great thing about this is using entity framework, it's using link syntax, stuff that you're already used to doing in your own code base, but we're getting that ability to do a similarity search locally. I'm not using OpenAI with this at all. It's all running on this machine. It's not making any API calls out. And this is going to return this record. So it's going to find those 5 similar objects or 5 similar document chunks to the text that's coming in. So I kind of jumped over it. We take the text in, so the English that I asked for, then we have to get an embedding for that so that we get that vector or that array of floats back so that we can compare that to what's in the database. And this is the whole gotcha with the vector type is you're doing a lot of math with this vector distance over all of the vectors in this table. So we're ordering by it. We're not, this is doing an order here. So it's not in the where clause. So we've got to see how similar it is to all of the items in the table. If we wanted to do a subset, and you most likely would, especially this is another beauty of it being in Azure SQL, is if you needed to join this to something else. So maybe you only wanted certain page chunks to be available to certain users. Well, it's in a SQL Server database. You already know how to deal with authorization in SQL Server databases by adding where clauses to, maybe a table that has the claims that a user has access to sort by or to filter by. So it can narrow stuff down because it's already in you're working with in the same database that all the other stuff is in. So this is the beauty of it. It's the same stuff they use for your applications on a day-to-day basis. So what I've focused on so far is really just the SQL Server or the Azure SQL side of things. There in this lab, there is the other portion. So this is just kind of included in the starter. It's kind of the command line parsing logic. Didn't figure there's any reason for me to walk you through how to build this out. So it's kind of included with it. You had to fill out these pieces, but the chatbot piece is here. This is a loop that pretty much captures the user's input. So here's the prompt. I type the response in. It takes the question, and then it adds it to this object that Semantic Kernel uses called chat history. What that allows you to do is, say, ask a question like, what is hybrid retrieval? And then it respond, and you can say something like, well, is it good in this scenario? And I use the word it as opposed to reusing the phrase hybrid retrieval. So the history allows a short-term memory of types in your conversation with the LLM back and forth. Because Bill mentioned that it's stateless going back and forth. It doesn't know what you asked before unless you provide it a sort of history, and that's what this chat history object does in Semantic Kernel. So I initialize a chat history before we go into the loop with kind of a persona. When you're playing around with the lab, you may want to add be brief with your responses on here. It depends on what document you decide to chat with, because it can be quite verbose when it's coming back, and you may want to keep your tokens down. So be brief with your responses really does shorten up the conversation going back and forth. But this is kind of a boilerplate loop for the chat history. All the logic is really done in this plugin. So this plugin is the one that is calling that retriever that we saw. It's saying, give me five most similar objects. This is why all that text is going out to the console. So if I comment this out, then I have a prompt. So this is a semantic function. So it really is similar to the prompty stuff that Bill was showing you. This is the prompt, the actual prompt template, and then this is the configuration to use when it calls the LLM. So this is just a basic RAG prompt where it's saying, a little about this is your friendly assistant, blah blah blah. This is the sources to use, plugs in those similarity search results, and then the user's question. So it's a bare bones RAG template there. Okay, cool. So the and so this is a plugin that is doing the search, and then it makes the request to the LLM inside of this plugin. You probably wouldn't really write your RAG application like this, because this is kind of a two-step away. But with Hands-on Lab, it works out really well because it gives you a nice clean loop here, and we're not doing a bunch of function stuff inside of the chat loop. But it's all in that plugin. Plugins right here. So this is it. So it has a little bit to do with semantic kernel, a little bit to do with Azure SQL, and it is on my other screen. No. Anyways, we'll give you the links. So let me go back to my presentation deck. I believe I covered everything. So we looked at the smart components. The AdventureWorks, I showed you the embeddings of the similar, how you can use that to find similar products, because we're doing a similarity search by the products, and then the categories. And then this is the RAG demo that I just showed you. So the using the vector search with Azure SQL. And yep, so this is a link. I will be doing a blog post tomorrow. If you don't know my blog, it's jasonhaley.com. So it should be easy to remember. I'll be doing a blog post that that posts all this information. And I have this slide deck here that has the information with semantic kernel, smart components. This is that EF core extension to use so that you can to add it to your code. And then this is a video by Steven Sanderson, who, if he's not the author, he's one of the main authors of the smart components. And he has another GitHub repo out there called eShop Support, which is demoed in this video here. The presumption of this is to work AI into normal applications. So he does things like, how do you do summarization? So it's a support ticket app. So he will create a summary of what the support ticket is. Categorization, you know, what type of question or statement is this user making? Is it a bug? Is it a question? Is it a product issue? So a categorization using AI versus some conditional logic. So he has real examples of other ways that you can work AI into your .NET applications. So these will be posted tomorrow. And any questions? All right. Well, very quiet night.
Well, while we're looking for any final questions, let me share my screen for just a sec, Jason, for some upcoming activities. Am I visible?
Yep.
Okay. So I don't want to prevent anybody from asking questions of Jason or myself. If you still have them, please unmute as soon as I'm done here, or just post something in the chat and we'll read it. But this Friday, we're going to have a similar event to this, probably be tweaked a little bit, but that'll be at noon. Signups are on North Boston and Boston Azure meetup sites. Not a Boston Azure event, but Friend of Boston Azure on Saturday, November 23rd for you local folks. The rest of these are all for local folks. Code Camp, Boston Code Camp number 37 out in Burlington, Mass. And then on Friday, December 6th, we have the space. We haven't done much recruiting yet, but we'll be opening up a sign up for this. This will be during the workday on Friday, December 6th at the Microsoft office in Burlington, same place that the Code Camp's happening at. We're going to do a significantly more in-depth version of today's talk. You know, things thematically, some of the stuff in today we'll just we'll expand it substantially. And there'll be hands-out labs and so forth. And Jason and I will be doing this along with Juan Pablo Garcia from Microsoft. And then we're going to do another one of those. There's the one that we're going to do on December 6th. We're going to do one in January to be determined, except at NERD in Cambridge, Mass. So more of this coming. If you have feedback or boy, wish you did X, Y, or Z, we'd love to hear from you too. So Jason said he'd still post his goodies to jasonhaley.com. You'll see mine on blog.codingoutloud.com. Any questions?